Welcome everybody. It's our pleasure to be here today, and we welcome you at the Sustainable Places paper session devoted to energy communities. Okay, the paper session will have several presentations which represents the work to be done in different EU-funded projects, and beneath that there is the work of leading entities, but also consortia. So I will go next. Just some quick rules for this hybrid paper session. So there are several people here in Nice, but also several people following us online. Please, virtual speakers, when I will call you, please share your own screen and also wait for some questions from the audience here, but also online. In-person speakers, please consider that your presentation has been collected and will be provided directly in this laptop. So when I will call you, please come here and join me here. And standing in front of the laptop in order for people online to hear you well. Then the time we start in, with a 10 minutes delay, more or less, supposed to be at 4, we finish at 7:30, according to the eventual discussion we might have together. Each presentation is going to start more or less 20 minutes, including question and answers. Let's see if we need more. Of course, it's an hybrid way, so we are doing our best to have a wonderful experience for both you people here in Nice and also people joining us virtually. And we will monitor also the chat with eventual questions, comments, whatever. Now let's start. Enjoy it. So first of all, I would like to call for Tomi Medved. Tomi comes from the University of Ljubljana. He's here in person. The second in a row, while we are waiting for Ilaria Pigliautile, University of Perugia, joining us online. And we have Blanke from the Munster Technological University, joining us in person. Then Gemira Martinez from Enedis, Sven Tischer Sven Tischer from E.ON Group Innovation, online as well. And then, last but not least, Andreas Tuerk from Joanneum Research, here in person. Thank you. Yeah.
So,
Coming.
I will set your presentation.
do you have a clicker or a pointer? Or?
No, I also try.
Just.
Do you want to stand up?
Yeah, if it's possible.
Yeah.
Whether
No, that's fine. If you want to move
Okay.
yourself, or you can move.
So I can start. So welcome everybody from my side. Like Sarah already. Yeah. Said, I'm Tomi Medved. I come from the University of Ljubljana. I'm a head of laboratory of energy policy at Faculty of Electrical Engineering, and deputy coordinator of Project Compile. Now, my first question is: how many of you have already heard about Compile? Okay, good. For those who you haven't heard, Compile is a European project, Horizon 2020, that is basically doing, let's say, energy islands, but not in a geographical sense, but in a network sense. So we have 5 different pilot sites around Europe, from Portugal, Spain, Slovenia, Croatia, and Greece. And we define the energy island like it can be from one building to a neighborhood, to a village, or even a small city. So that's something. Okay, what I'm going to present you today is one of the surprisingly successful result of Compile, because Compile is actually finishing in 2 months, so end of October. So we're at the end of the project, and this presentation. Here, what I'll present is a maturity scale. As you can see, the number of energy communities is growing fast, and they're all based on shared ownership, open environmentality, non-commercial aspects. But what we saw is that energy communities are facing a range of barriers. How to recruit the members, their regulatory resistance, access to public funding, member Tischer. So, how to support energy communities in their whole process, yeah, of let's say developing. Is there a way of, say, to guide them through the development? We came up with the partners, Universtiy of Research and LocalRES Group came up with this idea of, let's say, assessment of maturity. And what is maturity? Basically is a community readiness, resilience, and capacity to withstand the ups and downs when you're starting creating the community and also facing some challenges. It's like I said, the idea was to develop a self-assessment tool for the organizations and help them with the development. Like I mentioned, the main two partners contributing, LocalRES Group and Universtiy Research. How to do that? This self-assessment tool. Basically, we started with this framework structure. We said, like, okay, the energy communities when they start, there are different stages. You don't have to deal with all of the things at once, yeah. So we were looking for basically how to make a cooking recipe for the energy community. And we developed this. We started with the framework structure. We have stages and we have different factors, as you can see it here on this canvas. And the first, basically this is taken from, it has a scientific background, of course. And you have these factors, which are either a community factor. We started with community factor, so the capacity to collect social capital, staff organizational, know competences, what is really important, financial, political and network, and technical. So we defined those 5 factors at the beginning, said, okay, we need to look at this for each of the community. And then there are stages, because like I mentioned, not all stages, everything needs to be done at once. So in general, stages in individuals go from contemplation, preparation, implementation, and then the maintenance. But in a group, you need to start a group to develop a vision. You need to develop a project plan, collect resources, and structure an organization, and then maintain and grow the community. So basically, those are the 4 stages that we defined, and that's why we have that canvas where we have stages and we have the factors. What did we do afterwards? You need to have indicators. So we have 43 indicators, which are basically were taken from previous studies, and the indicators are developed into basically into 2 groups. Either is a threshold indicator, like a tipping point when the community like understands profound change. For example, establishment, like you establish it once, yeah. So establishment, like a legal form. Then if you have one legal form, that's like you're done yet. So it's a threshold, and there are some like continuous, indicators where you, let's say, need to develop or learn more or always recruit new members, taking care of various things that are not just once at a time, but they're repeating. Each indicator is described by impact mechanism, and there's no ranking between them. So how does this work again? I'll show you. Basically, I don't have it in person with me at the moment. I didn't bring it, but we made these indicators in a like a deck of cards. You have all the materials on the website. You can actually download it and print it. And we had these workshops where 3 to 6 representatives were actually, we had like workshops where they use this. So you have a deck of cards, indicators, and then you start placing them. You read the indicator and you go like, okay, is this indicator, where would I place it? Where is it important at the beginning? Under what factor it goes, etc. And we had these workshops where we handed out the indicators, the deck of cards, the canvas, and they were like, one of us was monitoring, or let's say, being facilitator of the group. So the group was thinking, okay, what their goal is, and they were. Oh my goodness. They were looking at the indicators and they were placing them. Yeah. And what was interesting, so results, we always, at the end of the workshop, we took a snapshot of how they placed the cars. We also, because it was a development thing, we said like, okay, say if they're important, non-important, and what we saw like that, when you start a group and develop a vision, the most important for them was like 13 out of 16 workshops. They said like, okay, shared vision is important. The number of members, they found it like quite important. Specific decision rules that you need to define at the beginning, and that the business plan should exist, that they know what they're doing. In the second stage, they were all putting like more or less license or permits to start things. Of course, business plan was even more important now in the second phase. What's interesting that in this, that already in the starting, when you're starting making creating a plan, you need to establish a relationship to local authorities. They find it quite important. And of course, the legal form, which one, what at the beginning, in the first stage, it was not that much important. But then, of course, the more you develop, you start thinking about what legal form should I take. And then in the third and the fourth stage, they found it important that you need to have capital and assets, and especially important also like these the members' feedback mechanism, so that the members can say what they like, what they don't like, what's important. The irrelevant indicators that we identified are the numbers who are not, of users who are not members yet. At the beginning, this indicator was there, but then like most of the guys are like, hey, we don't think this is important. They didn't think about what was interesting. They didn't think about it. Refining the shared vision was important, because they said like, okay, we have a shared vision, we need to stick to it. And it's not that you need to redefine it all the time. The depth and inclusivity of decision making, they didn't find it that important. And a number and diversity of key personnel, they also didn't find it important, that you need to have covered all the, let's say, the aspects, the legal, the technical, the social, whatever. Even though you think that you need to take, into consideration everybody, they said most probably not. And then regarding the other factors, here it's very interesting, and I will say afterwards why maybe these results. They didn't find a relevant indicator, the return on investment for the member or the profit margin, which goes in line with the energy community thinking. They didn't also think that the transfer to other communities is important. Reliance on public funding, also they didn't think that this is important, because you're an activist. Yeah, you need to provide, you need to do it by your own. And they were also not interested in providing, let's say, multiple services or value stacking, because even having an energy community that deals just with one thing is more than complicated now. Like, you can provide flexibility, or you could sell apples, you could, I don't know, whatever you want to do. It just adds complexity, and maybe that's like really the last stage that you could try to manage this. And yeah, they didn't also think that the growth rate or proportion of energy produced consumed is important. Okay, based on this discussion, what was the main issue? What was the main? Why did they think about that? It's one of the things which, how to say, because I personally always thought that the return on investment is important, etc. But then, our workshops were consisted of mainly activists and mainly the guys who are just we are here to save the world. And of course, this is, I wouldn't call it irrelevant. I would just call it that we didn't, take a good.
It's not representative.
It's not representative in that sense. But it was really, it was a good example on how to do it. And based on this our feedback, we also reduced, because there were too many factors, we reduced from 5 to 3 community factors, technical and environmental. And we are now redefining also the indicators. So a new set of cards will be, we will release it just before the end of the project.
5 minutes.
Yeah, it's perfect. I have, this is my last slide.
Cool.
Yeah. So the maturity frameworks, the idea is to support energy communities in anticipating future stages and identifying potential challenges and opportunities. It should be seen as a practical guideline for actors and not as a ranking tool. So critical thresholds, what they identified is that you need to have a shared vision, you need to have a decision rules among the members, and that we need to have a business plan, license permit, and legal form. Those 3 things are crucial when you start if you want to make your energy community work. Those are the crucial parts. As for that, you would see, it was really interesting. In the first stage, let's say starting with an energy, there were only few indicators, you know, like everybody can get enthusiastic, but then the second developing was like most of the indicators were there. And it also goes on, it really reflects basically how every project goes in that sense. And it's a good thing that it's basically just a guideline. You need to take care of this, and this at what point. It's basically, how would I say, like a project management tool for the energy communities. Yeah, exactly. And when you put this in a form of a card, everybody reads a card, it puts it there, they think about when it's going to be important. Yeah. For example, it's like building a house, I would say. Yeah. So we need to start with first where we would like to build the house, then what kind of house, and then what kind of furniture we will put. Is this in the last stage? Yeah. Don't bother with that in the first stage. Don't bother with I don't know what kind of color of your dishes will be, or the curtains. Yeah. At the beginning, you first need to define the main important pillars, and this is what our this maturity scale does. And also afterwards, in the last page, the last stage is that it's like the maintenance afterwards. When everything is running, what do you need to do to keep it up and keep it up running? Yeah, cool. I think I was under my 20 minutes.
Yeah.
Is anybody any questions or comments? Yeah,
please.
Yes, I have a question. Thank you for really interesting results. On the one hand, you stated that the people think it's really important to have a business plan from early on. They even stated that in 2 different stages. But on the other hand, I can't really see the goal of the community if they also state it's not interesting to have a profit, it's not interesting to have return on investment, it's not interesting to have social or environmental benefits for the community. So I don't really understand how that makes sense.
No, environmental, and this was important for them. The business was not that important for them. That's but that's I would say activist thinking. Yeah, I do it for the nature, for myself, for everything. Unfortunately, I mean, as soon as you go away from those guys who do it anyway, yeah, those other things become an important thing, an important factor. So, like I said, those are not representative. I'd say, at least in my opinion, not representative, because, like I said, the people who were there were already, you know, totally engaged. In other research that we did, of course, this was very important. You will, especially now in energy crisis, etc., like people are looking how to save money, how to get. It's not that we're just gonna do the solar because it's fun, yeah, or whatever. It needs to make a return on investment in that sense. And it's also, you know, the business plan does not. I mean, the plans how to make or why we were doing it doesn't necessarily for the activists mean. When they say business plan, it's more like what will we do? It's more like a project plan than a business plan. It doesn't involve that much of a finances. It's just like, hey, okay, we're setting an energy community. What will we do in that sense? and then they call it a business plan, because you need to know that you will install, how much you will pay for something, etc. Yeah,
Please.
Thank you, very interesting, and I think it's very useful to have this kind of structured approach, like for the business models, you have the business model canvas.
Yeah.
It's like checking that, have I done this, have I done this? Because it's very useful that you have covered all the important factors there. Good idea.
I mean, I'll say personally, I'm a technical guy. So when they proposed this, I was like, okay, guys, you know what you're doing. I mean, I'm not gonna be a judge in that sense. But after a while, I was on these workshops and I was looking at that and I was like, this makes sense. It actually makes sense. And the feedback that we got from the stakeholders and also from the other partners, it was amazing. And we already have like a continuation we are pushing this idea forward in some other projects, how to develop it even more.
And it seems like also, just a comment, it seems like you're using also sort of gamification.
Yeah, gamification.
Which is quite useful because you make it interesting, taking decision together, and also in a maybe more direct way.
Yeah. As soon as you give somebody something physical, and give them a card, and they look, nice cards, nice design, let's read it.
Reality.
That's reality. And there's a canvas, and then you start putting in, and then they're talking. Should we put it like this? Should it like that? So it makes it also, let's say, speeds up the conversation and everything. Okay. Anybody else?
Anybody else?
One?
Yeah.
The project is over in 2 months, I guess.
Yes, end of October.
I think maybe you are also leading the exploitation of this project.
Sorry?
You are leading the exploitation activities of the project.
Leading the exploitation.
Yeah.
I mean, you have just mentioned that you would like also to propose this solution in other projects.
Yeah, we are already including it in some proposals. It's like this. This is not like, if you look at the exploitation plan, we're not going to make money out of it.
Yeah, that's my question. I mean, what's the strategy that the consortium?
The strategy of consortium, we had a very interesting, how do you call this, IPR. I wouldn't say it's all IPR. Yeah.
All the partners.
Yeah.
It was important. So
it was important that the IPR goes, and I'm mentioning here like Joanneum Research and RES Group PPP. RES Group, which you most probably know, the organization, and basically also all the members we can use it in our let's say further activities. But there's this Creative Commons licenses that we will license, and it will say this was developed under Compile, mainly by those and those, and you can use it and develop it further, but just to be recognized for our work. It's not. It's a non-profit thing, and we include it into a replication platform. We will keep it online. It's freely downloadable at our website. Our website will stay for another 10 years. So hopefully people will come, download it, and of course with every new project we will carry it on. That's it.
Okay. I think that's all. Thank you. Can you see it? I would watch this one.
And if somebody is interested, you also have a brochure how to use it, a working paper, everything on.
Following up the promotion.
Yes, you should look at some 5 minutes.
You're using this one? No. Okay, perfect. Sorry. Okay, so now Yeah, we have Julia Blanke from the Munster Technological University presenting us. LocalRES.
I have to apologize, first of all. I wasn't expecting to present twice, so it is exactly the same presentation like I had before. So if you have seen it already, please grab a coffee or just quick event. You have 12 minutes, so I'm really sorry for that. Okay. I am presenting the LocalRES project, particularly a case study of European small-town renewable energy communities. And we show the participatory design of supporting tools as a vehicle to engage and understand local communities and their energy-related concerns. So we are currently having a shift of paradigm in the energy sector. From mainly, for example, a few larger power plant productions to small power producers, or from centralized markets to a more decentralized approach. This implies in particular that traditional, more passive consumers need to take an active role. So looking at the technological side only, the technologies for this transition, the technologies for this transition is already available at a high TRL. So why are we still not there yet? Recurring issue when we are trying to implement new technical solutions is that people need to be kept on board. This challenge has been acknowledged more and more in recent years, and we can observe a policy shift from focusing on purely technical solutions towards social innovations. For example, the clean energy package is not just looking at technical solutions only, but also is interested in social aspects. And one important example is establishing renewable energy communities as a new focal point, and that aims to encourage more citizens to get actively involved. So, how to define a renewable energy community? It is intended to be a legal entity which must be voluntary and autonomous, with the primary purpose to provide environmental, economic, and/or social community benefits. So the renewable energy community is a vehicle to address some of the social challenges of the energy transition. We can identify three main social dimensions in the context of the energy transition. First, the energy transition needs people to accept new technologies in their daily lives and adapt their behavior accordingly. Second, people must engage on an individual and on a community level. And finally, they have to decide on investments and participate in the operation of the assets and systems. Therefore, social innovation along all these axes is necessary. The LocalRES project and its activities can be visualized on the three described levels, and it is focusing on local energy communities, technological scenarios, and community goals. Tools like our webpage can support renewable energy communities, for example, by helping to understand technical or social implications of community goals and scenarios. So if we want to be serious about involving citizens in the energy transition, we have to make sure that we develop relevant technologies with them instead of just for them. And this approach has been called participatory design or co-design. And the idea is to involve all relevant stakeholders in the development process from a very early stage. And this gives everyone a voice and provides valuable insights, not only for the products to be developed, but also into the community itself. So in LocalRES, we use the two-step approach to understand the local energy communities in the project pilot sites. We started with a series of representative workshops together with the community leaders to identify specific goals and scenarios that are considered to be relevant for the different communities. Based on this initial understanding, we developed and ran a second phase of workshops with the citizens of the communities to collect their feedback on these goals and scenarios, but also, and maybe more important, on their needs and concerns around their own energy community. We collected both qualitative and quantitative data, and I will present both on the next slides. So first, the LocalRES pilot sites are all small towns in different regions of Europe. And we have Črka, it's a little island of Finland with around 200 inhabitants. We have Espasta in North Spain with around 750 inhabitants. We have Ollersdorf with around 1,000 inhabitants. It is in Austria. And we have Berkida, which is in Sardinia, Italy, with a little bit more than 2,500 inhabitants. Important to recognize is every community was very different in its stage of development and focused on different goals and systems. So the renewable energy in community in Ollersdorf presented itself as the most advanced and well-established community of the four we engaged with. And the workshop participants were mainly older and male. And that was something we found to be the case across the board. One of the main community goals was to achieve 100% renewable energy for the community, for example. So Berkida is part of a couple of EU projects at the moment. As we heard in the previous workshop, it is also part of Hestia. In comparison to the other three pilot sites, LocalRES, their focus was very strongly on the financial aspects of renewable energy communities. But there was also a discussion on privacy issues around supporting tools. So consequently, one of the main goals here was to save on the cost of energy. Espasta is a very young and not yet fully established community. So therefore, the workshop offered the opportunity to discuss general aspects around creating the community itself. And here a specific scenario of relevance was, for example, upgrading public buildings like the school. And finally, the citizen workshop in Črka was completely different. Participants showed that they had a general interest in the overall project and the other demo sites. And there was a strong focus also here on how to establish so-called heroes or energy champions to improve the communication between energy experts and citizens. That was a major issue in Črka because there were participants who had really problems understanding the question, for example, of the questionnaire we provided. So they really were looking for a way to facilitate the communication somehow, that they understand what is going on and what is asked of them on what their benefits are to participate. So one specific scenario for Črka was, because it is an island, is the development of EV infrastructure, and not just for cars but also for boats. So let's look at some quantitative key findings, which we collected, like I mentioned, by providing a questionnaire during the workshops to all participants. And the presented results are a selection of statistically significant ones. So everything else I don't present, so only a selection of significant, statistically significant results will be presented. So first, we try to understand the engagement with the renewable energy communities in general. And we found that overall male participants have been more likely to engage with renewable energy community activities. So then we looked at how supporting tools can be used to support renewable energy communities. And we observed that participants who were interested in taking part in the decision process also found that a supporting tool could be helpful. While in Berkida, as mentioned before, the privacy issue could be shown as a major concern regarding the use of supporting tools. And this we didn't observe with any similar significant correlation anywhere else. So next we asked the question for whom the tool should be developed and designed for. And in Odersdorf, we observed a correlation between age and expert use. The older participants didn't want the tools to only address experts, but at the same time, they also did not want to use the tools on their own. So what does this mean? This implies a desire to co-design the renewable energy communities in a group setting amongst the older age group, whereas younger participants are leaning more towards expert and individual use. And finally, we looked at the preferred platforms for community supporting tools. And participants in Berkida were more interested in mobile app compared to Twitter and Odersdorf, and the latter being more interested in a web page, although younger people there were also leaning more towards a mobile application. What this shows is that the target platforms need to consider different demographics, the different references, and also technological literacies, because all the participants also looked for non-electronic means of communication. And in Odersdorf, we also observed a gender difference, with female participants preferring mobile phone applications and male participants preferring a web page. Sorry, Julia, you're finding it. Okay. We also evaluated the qualitative feedback from participants during the citizen workshops. We identified 3 main areas of interest that were technical, economic, and social. On this technical level, participants would like to see more real data used and understand the financial impact achieved by the energy savings. And however, what feedback really showed was that the development of the community itself was a topic of primary importance to many participants. And communication and coordination between the members of the community was mentioned frequently as an important aspect of supporting activities and tools. So the limitation of the study has been the selection bias. Only interested parties took part in the workshops, and we observed a strong overrepresentation of all the male participants. So what are the implications for renewable energy community? To establish and support renewable energy communities, 3 points need to be considered. The technical side, the financial and economic implications, and social dimension and communication. And furthermore, specific requirements on an individual and community level need to be considered as well. So what is the take-home message? Renewable energy communities are a novel approach to address the energy transition. Not only the technical, but also the social dimension needs to be addressed. And finally, co-creation can foster active engagement and empower citizens to take part and make informed decisions regarding energy community relevant topics. Thank you. That's really good.
Thank you, Julia. So we have some minutes for any question here from the room or online eventually. Please. Okay, Dana.
And do I say it here or do I?
If you prefer, I prefer coming here, but if it's short, I can.
It's just a comment on the results regarding the domain, and the gender aspect is interesting because that came up in our survey for REAC. And I was wondering if you had the opportunity in LocalRES to think about how we might be reaching women.
It's a very difficult question, I think. We see over a different, in different projects. the thing with LocalRES is gender isn't really the main focus. We are trying to address the decision makers, and it might be disappointing, but in this case, it seems to be all the male participants, so who are interested and who are the decision makers for these things. That doesn't mean that we shouldn't address the women of the community. But it is a very difficult thing how to do this, so I don't have an answer to that. It's just we need to keep this in mind, definitely for further projects and developments, that this needs to be definitely considered and focused on to get everyone on board.
Thank you. There is maybe another question?
Yes, sorry. You mentioned that for the elderly men, specifically more elderly women, there is this intention of using all means of information such as paper. Okay. Once the digital divide is gone, let's say in 10 years or 20 years, this is supposed to happen. These people are technophones, so they prefer this other means of communication. How do you explore whether this is going to be the same? Whether people aging will, even though they're able to use technologies, will prefer again as a previous generation paper, or would you think that problem will disappear?
It's a good question. I think you have to constantly engage with the community and see what the needs are. So it's not a static situation, but it's evolving. So
okay.
I thought you wanted to say something.
The question is that, for example, if you manage to make a very easy interface with a machine or the device or application they have to use, that should be help them to get into not only into getting more activity with just their own energy devices, plus also maybe you can even encourage some sort of challenge of participation through the device or the application. So this is something we're exploring so in React and I just wonder how to go forward.
Yeah, I think important is to really assess the individual needs of the community and really address different platforms. It's not just the one or the other. You really have to consider all needs and all preferences, so to reach as many people as possible. Like women also, they might have different needs. The problem is we don't know because they didn't participate. So it would be very interesting to make a study really addressing the people who didn't participate, like younger people or women or maybe disadvantaged people who think they are not included in something like that.
I fully agree with you that you don't have to force to use one channel. This is absolutely another way. So yeah, this is my question.
Thank you. Thank you very much. Sorry, but thank you for your presentation. So now we have Sven Tischer from E.ON Group Innovation. No?
They will share.
They will share the screen, sorry. Yep. So, then some quick introduction, very quick introduction by yourself, and then you can go share your screen. Thank you.
Thank you. I think Gemira will be sharing the screen as we're co-presenting.
Oh,
Yeah. No problem. So I think it's the screen, so I'm just finding the button to share.
Gemira Martinez from Enedis.
Yeah, but I think you need to leave your sharing, but I cannot take the control. Now I don't see the button here. Okay, wait a minute. Here. I think this one. Okay. Can you see it?
Yeah, please put in your presentation mode.
Yes, normally it's on presentation mode.
On the right side, bottom, there is a sort of...
Yeah. Yeah, in fact, the fact that once you were presenting from your side were also in this mode. So wait a little bit. Wait.
Yeah.
And now it's better, I think. Yeah, sorry. So hello, I will let Sven introduce himself and then we can start.
Oh, I think for me it still looks not in presenter mode. I'm not quite sure how it's for the others, but
Yeah.
Okay, sorry. No, okay.
but while I can anyways quickly talk,
It's fine, we
that
can-
it works in the
It should be
meantime.
okay now.
Okay.
Okay. Sorry.
Then from my side, so my name is Sven Tischer. I work for E.ON Group Innovation, and I am technical director of IElectrix since when we started the project, beginning of 2019. Gemira?
Exactly. And I am, yeah, you can hear me? Yeah. So hello, I'm Gemira Martinez. So I am the PMO of IElectrix project, the same from the beginning of the project in May 2018. So today, the goal is to present you the results and lessons learned from the IElectrix, from this IElectrix project. So we are going to present both together with Sven. So to start, I just want to give a quick overview of the project. So IElectrix is an H2020 European project, and we have started, as we say, in May 2018, and the ending of the project was initially planned by the end of October of this year, but due to some delays we experienced in some of the demos, we have requested an extension of 4 months. The consortium is formed by 15 European partners and one
Gemira,
Indian
I think
partner.
we're still on the first slide, right?
Yes, please.
Yeah.
Would you please show it?
Okay. Okay. I am seeing the second one, so yeah, it's weird.
I recommend using the reading mode for the presenter.
Sorry.
It's the button there. It's now
Yeah, now we can see the second.
Now we can see the second one. Yeah.
Okay, please.
But the
Okay.
reading mode.
Okay.
Yeah.
So
We cannot. Yeah. Please go on. Thank you.
okay. Okay, so no problem. So as I was saying, the consortium is formed by 15 European partners and one Indian partner, which is the DSO Tata Power Distribution Delhi. The coordinator is Enedis, where I work, the French DSO, and the technical director, as Sven say, from which Sven is here now, it's E.ON. The global goal of the project was to test the technical and economical feasibility of the implement of 5 DSO coordinator real scale demonstration that were implementing IElectric island system and a microgrid in the case of the Andean demo that I will explain in detail further. As the pilots were implemented in 4 different countries, this means that the context locally and also the problems that they'd face were different. So first we have the MOVE demo installed in the municipality of Friedland in Germany. In this case, we have a rural area that has a massive renewable integration, and here the solution was to test a battery storage system in order to see the impacts on the postponement in the grid reinforcement of the NB grid.
Sorry,
In
Gemira,
Austria,
we're still on slide 2.
Okay, I'm sorry. So I will stop because I have there is a problem. Yeah, you cannot see it.
We're still on slide 2.
Because you have the power slides. Unfortunately, we cannot.
I have changed. This is weird, but because I have changed and.
Maybe Sven, do you have it? The presentation?
I can try. Just give me a second. That will work.
Yeah, I'm sorry because in my screen, I don't know if it's problem from my connection or something because I have it.
Now we're seeing slide 3, but
You see slide 3 now? Or
Maybe
not
there is
yet?
Yeah, we do now. It's just not in presentation mode. That's the thing. I think you might be sharing the wrong screen.
Okay. Normally, okay. No. Okay, so now you have it. Okay. You see it now?
So we see like page number 3, but not in presentation mode.
It doesn't matter.
It doesn't matter.
Okay.
We see.
Okay, I will go on like this because otherwise I won't keep the time. Okay, so as I was saying, so
Thank you.
sorry, I'm having trouble to hear you. It's really like cutting a little bit.
nothing, just go ahead, please.
Okay, sorry. Sorry for the inconvenience. So as I was saying, so the second demonstration is implemented in Austria, in the municipality of Gusing. And here it's a rural area with an existing local energy communities where the solution test is a battery storage system and a demand response program in order to reduce the peak load, the voltage variations, and also to optimize the self-consumption and the self-sufficiency at the level of the energy community. Here we are at the low voltage grid, at the low voltage level. Then we have the Hungarian demonstrations, which are located at 2 different sites. First, we have Sanke, which is a touristic area that has experiences a high peak load during summer, especially at nights. And we have also Dush, sorry for the pronunciation, it's in Hungarian, which is a small rural area with that has reached its maximum PV hosting capacity. In this case, the solutions that were installed were a battery storage system as well as a direct load control to reduce the peak load, the voltage variations that are created with the integration of renewable energy sources, increase the hosting capacity of the medium voltage network of these renewable energy sources, as well as to optimize the local consumption of the rest. And finally, there is Shakti demonstration, which is implemented in Delhi, in India. And in this case, it's a little bit different because we are in an urban area and with an increasing duration of PV installations. And the solutions are a little bit different. Here, we have installed a microgrid with an islanding capability, as well as a demand response program to improve the resilience and the quality of the local energy community supply at the low voltage level, and also as well to maximize the local consumption of the renewable energy sources. And now I will pass the floor to Sven, that we will present you the main experimentation results and lessons learned for the 4 European demonstrations. I hope.
We're still on slide 3.
Yeah, I already passed. Okay.
No.
I'm guessing I have to change each time. Can you try to share maybe?
Oh, we're now on slide 5, so it works. Oh.
Yeah. Sorry.
No, there is only a small.
I'm so sorry.
No, don't worry.
Sven, would you share?
I'll try now. Yes, 1 second.
Great. Thank you.
Just trying to organize my screens then. So.
Oh, yeah. It's okay.
Can you see? You should see everything.
Yeah.
Yes.
Yeah.
Yeah. Very good.
Normally, yes.
All right. So then first demonstration is in the northeast of Germany. It's called Möwe, where we've installed a 500 kilowatt, 1 megawatt hour battery, which we also integrated into the SCADA system. So it's like steered locally. The region has a massive overproduction of renewables. And we also like try to include community, engage them, and try to increase energy awareness in this area. When it comes to, let me just see if the slide switches, very good, yeah. So main results, and I guide you through this quite quickly because we're a bit late of time. So then basically 3 things to mention there is first of all, congestion management. So we like tried, one of the main use cases was to see if we can like reduce curtailment of renewables. And we managed this by 2 to 4% in our testing period. Sounds quite little. It is because we have a massive like 200% overproduction in renewables compared to the load. And with a much bigger battery would have managed to like have avoiding more renewable curtailment. What is quite interesting, if we're looking into the second block, improving local energy management, and they actually were quite some good results. So we managed by like storing locally produced energy, green energy it's mostly PV in this area. We could reduce CO2 emissions by 20%, could increase self-consumption by 13, and also self-sufficiency by 20. This we think could even be further optimized if we would like optimize the running or the operation of the battery towards improving local energy management. And the last point on the left side is also network stability. So we did a simulation, and in simulation we came out that we could reduce the ROCOF, the rate of change of frequency, by up to 40% by providing virtually nature from the battery, which will become more and more important in a energy system without rotating masses. So basically standard like old-fashioned power plants. When it comes to lessons learned, I will summarize those very quickly. There's 2 main learnings. So the first one is regulatory. Regulation is just not there for DSOs to have batteries on site. And the second is internally, DSO like never installed batteries before. For them, it's a new asset. So none of the processes from procurement to installation to interfaces does exist. And this was like quite something in the beginning. For the second demo site, which is in Austria, it's called Stromgüssing, in the area of Güssing. This demonstration is not as far advanced as the one we just seen before, because they had quite some massive delays. It's a very small battery. So if you look at the bottom left, it's a 50 kV inverter and 100 kilowatt hour capacity. What they do though here is also they have a demand response framework. So they installed assets at real customers, be it smart lighting, HVAC, and DHW systems. What they try to see here is if they can introduce and improve flexibility and through forecasting and schedule in a local energy storage system, and want to improve the resilience in a distributed energy system. For main results, as I said, they're not as advanced as the other ones. The idea or the plan is to also here improve self-consumption to avoid renewable curtailment, to do peak shaving, and regulate the voltage through reactive power management, but also to like continuously analyze demand response and optimization of self-consumption and self-sufficiency by like people and citizens around, and trying to provide flexibility to the grid. Also here, main lessons learned, this is on the people side in the top right corner, is you need to involve and include citizens at a really early stage, have a constant communication with them. We also find that motivation of participants is very different from simple monetary ones. I want to participate and I want to see money for it, or like altruistic ones, contribution to the energy transition. And what's very important, what we learned, it needs to be very quick and easy and painless for customers. It needs to be plug and play solution with basically no maintenance. And they also had similar same problems on the DSO side on connecting their batteries and having all the processes ready. For the third demo project, which was in Hungary, we actually have 2 batteries. So the first one, as Gemira said, in Zanka, which is quite a big one with 500 kilowatt and 1,200 kilowatt hours, and a smaller one in Dush with 250 kilowatt and 570 kilowatt hours. Also here, what's quite nice, the Hungarian colleagues provided actually an online overview which shows the status for citizens. They can see how much is actually produced, how much is our demand, is the battery charging or discharging, and this was actually quite popular among citizens in these areas. 4 main results. So there were 2 main problems in this area. In Zanka, it was the objective to reduce the voltage drop. So every time like PV fed into the grid, there was a voltage drop, and there was an improvement by 0.8%, which sounds really small, but it's actually quite big if you imagine that the allowed voltage drop is only 2%. In the case of douche, the main use case was to reduce increase of voltage, and this was reduced by also 1%. In both use cases, the battery storage managed to improve the voltage grid profile and reduce the line load of the MV line. What we also did there is there was a legacy system of control systems. So basically a separate meter for heating in households, which EDSO can control. And this was optimized and smartification that we can also use customer loads to improve grid situations. Here, lessons learned were also mainly amongst technical issues. So we had quite trouble finding suppliers for battery energy systems, and it was quite long development times for IT and the ICT on both sides, on the supplier and on themselves. And one finding they also had is there's obviously to find an equilibrium between, as a DSO, you want to control as many loads as you can, but as a customer, you want to have as little impact to your comfort as you can. So basically, there's an equilibrium that needs to be found, and there needs to be seasonal updates and control tables to control loads for people to make sure that they're always warm and healthy. And with this, I would hand back over to Gemira to present you the last demonstration site in India.
Okay, so yes, thank you, Sven. So the last demonstration, the Indian case, it's a particular case. First, because it's out of Europe, and also because we are the demonstration is located at a secondary substation, and it's located at the premises of a high school in Delhi. So this is quite particular because we could, among the solutions that we could implement and test there are the demand response program, and that had a strong community engagement and energy awareness, and most of all with the students that are almost 4,000 students in this school. As you can see one picture at the bottom of the slide. We had the opportunity to make sessions with the students and make even a contest with them, which was called Energy Warriors, in order to involve them in this energy awareness and demand response. So this was a really nice experience from a human perspective also. Then we, of course, there were innovative equipments and softwares that were installed in order to reach the goal of improving the resilience and the quality of supply of the low voltage level. First, we have a battery storage system that you can see on the left side, which with a capacity of 200 kilowatt, power capacity of 200 kilowatt and 274 kilowatt hour in energy. Low voltage energy control center that you can see on the right side, and this is the brain on all the microgrid, and which also allows, along with the battery, to make the islanding of the system in case of outage in the network. And here we have embedded all the monitoring and control system, the SCADA, the PMS, and also the energy management system. Also, we have installed a NVLV smart transformer with on-load tap changer that you can see also on the right side, and on the bottom you can also see a software that is a LV digitization software. This is a screen from the software, which learns the behavior of the low voltage network and allows to predict its behavior from a day ahead, in order to predict congestions and other problems on the network. For the demand response program, there are also deployed some smart meters. Yeah.
Let's go to the conclusion. Thank you.
Yeah, we are running out of time.
Yeah, okay.
Sorry to interrupt.
Okay, yeah, sorry. Okay, no problem. So I will jump to the results. So it will be quickly. So on the main results, we can say the main importance up to now was the detection of significant voltage distortions on the low voltage network, the improvement of the resilience of the low voltage network, as well as the implication of the customers, especially of the students, and finally, but really important, the improvement of the human and equipment protection against electrical hazards because of the system. Globally, for the lessons learned, what I will say is that it is complicated to adapt a system that was conceived in Europe to an Indian environment, because we have high level of importation costs, and we have a really harsh environment in Delhi with high temperatures and also humidity that can affect the functioning of the equipment, and also due to the newness of this equipment, this can be difficult to find the expertise and the pieces to repair it at the local level. Finally, I want to conclude is that with this project, the main findings are that using a battery energy storage system, we can help avoid the renewable energy sources curtailment, improve a local use of the energy in a community, provide flexibility to the DSOs, reduce network losses, and improve quality of supply, and improve grid resilience. But however, the implementation of this system is still has still high costs, and in case we want to implement this, it needs to be the financial benefits needs to be evaluated carefully and taking into account the regulatory context of each country. Thank you. And sorry for the time passing.
So thanks a lot, both of you, Sven and Gemira. Maybe there are some questions, quick questions from the audience. I know we have some time.
We don't have time for questions, but you can reach us, and you can reach us. You can look up the project online. You can reach us through the general channels if you have any questions.
Yeah, I'm so sorry for the technical problems. Well, maybe you can reach us, of course. Thank you.
As you will be learning today, also in energy communities. And the recording will be available by the end of September, more or less. So there will be some editing from our side, but then they will be disclosed to all of you in order to really watch cooling presentation, and also maybe other sessions that you missed. So thanks a lot. So in the room, Mia.
We didn't have this. Okay.
Yeah. We can show it. Yeah, we can show our screen with their slides. Ala-Juusela from VTT. Sorry, I mispronounced your name, maybe.
Yeah, no, it's okay.
It's okay. The last one. Ilaria will be the last one.
Okay, so I am Ala-Juusela from VTT Technical Research Center of Finland. I am the technical coordinator of Access project, which from the results from that project I'm presenting, or the first results of business models in that project. And we have here Andreas Tuerk, which is the coordinator of the project from Joanneum Research. And he will also be able to answer your questions if we get to that part at any point. So some words about the Access project. It's about flexible, user-centric, energy-positive houses. And we are looking at how near-energy buildings can be transformed into positive energy buildings. We are working on this subject for 5 years, starting in 2019. There's 21 partners from 8 countries, and we have 4 demos in 4 different time zones. The Access demos are in Graz, Austria, Helsinki, Finland, Kassel, Belgium, and Granada, Spain. There are 2 new buildings in Helsinki and Granada, and or to existing buildings in Graz and Hasselt. But the building in Graz is transformed to residential buildings. And because I'm talking about the business models for positive energy buildings, it's quite important to remind you of what is actually positive energy buildings. For us, it means an energy efficient building that produces more energy than it uses from renewable sources over the time span of 1 year. It has a high self-consumption rate and high energy flexibility. It's central for the business models. And also it provides high quality indoor environment, maintaining the comfort and well-being of the occupants. And also it will be able to integrate the future technologies like electric vehicles to maximize the on-site consumption and be able to share the surplus renewable energy to also other parts of the grid. So why am I looking at the business models? We saw that that was also mentioned in previous presentations that technologies at high TRL already exist. And there are also these kind of integrated concepts where you provide both the building and the renewables, the energy efficient building and the renewables. But these are quite immature still, and we're coming back to that later. And also during the discussions and literature reviews, we have found out that the business models are really a crucial element to reach a wider rollout of positive energy buildings. And they also seem largely missing. There are not mature business models that can provide and support these business positive energy buildings. And in this presentation, I'll highlight, so I'm not going very deep in the business model, just presenting like a selection of business models and key customers and value propositions that you can present to them. As I mentioned, this is based on literature reviews and also discussions with different stakeholders, also in IElectrix project, in these different demo countries and in different other workshops. And also in cooperation of IElectrix 83, which is about positive energy districts. So now let's go a little bit into the elements that could be included in the value proposition of positive energy buildings business models. There's of course the energy efficiency is important to have, and the renewable energy technologies that integrated into the building or the site, building site. And one element, one crucial element is the optimization of the energy demand and supply during the operational phase. This not only supports the site, the building, but also provides flexibility towards the energy grids. It can be electricity, but it can be also district heating or cooling grid. And also one element could be the ability to maintain the quality of the service. Like we mentioned that the human well-being is a crucial element in the positive energy building. So, for instance, providing indoor environmental quality. This, I'm not going very deep in this image, so you can find it in my presentation afterwards. But these are just, we have recognized selection of value propositions for different customer groups. If I take some example about, for instance, the one-stop shop, it's mostly relevant for single-family building owners because they don't know where to go to ask and what they need to do. So it's very good if they have someone who tells them that this is the order in which you should do your renovation for instance, or installation of the renewables. And the value proposition is this, that there's one point of contact towards the customer. So don't have to go looking for different providers. And then one emerging model is this aggregator also, that it provides, that's the type of stat business model, that it can take the value from, or the incomes from different customers, that they, for the grid operator, they provide the flexibility, and for the building owner, they provide cheap electricity. That's just examples of. And also this, as I said, there are different value propositions, different customer sectors, and there are different life cycle phases where they are most relevant. Like this one-stop shop that I mentioned, it's most relevant for renovation. It can be used for others also, but renovation is the most relevant. And then there's, for instance, life cycle contracting that is relevant for the construction and operation phase, the life cycles. Yeah. Then there are a couple of new models, and actually these were mentioned earlier also in this. And why I am in this energy communities session is that one of these business models is about the energy communities, and that is where Andreas is the expert. But then there is also these pay-per-service business models where the customer pays for the outcome. Like, for instance, that's more like professional building owners. They are interested that their customer gets this in a good indoor environment, and then they pay for that and not for the equipment or the energy. These are like new models that are emerging, and as we saw, that there are quite a lot of challenges that you need to find out if you're starting a business. There are different, in countries, different regulation, different socioeconomic conditions, different building traditions, different ages of buildings, different climate, and different availability of renewable energy. And it's a good idea to start building the business first in one country and then enlarge it to another country after the learnings that you got. Then there are some challenges. Also those different environments is a big challenge, and positive energy building is a quite complex system. This is my last.
Oh, thank you. Sorry.
Requiring a lot of knowledge of the different fields and companies that have to have some new skills. And there was a need for integrator, and that was also mentioned in previous presentations, that regulations are somewhere, and they are different, they are immature, they are not working for this section. More understanding needed about real needs of customers. This came also up during these presentations, and also they're willing to pay for the services. They don't understand what they are getting always. Yeah, contractual agreements are needed. And then there is the question, if you're looking of building or district level, are there some advantages about that? And that was related to the energy communities also. That was quick.
Thank you.
Yes. And if you have any questions, to Andreas is also available.
Thanks a lot. Thank you. Any questions from the people here?
Still 2 minutes left.
Yeah, of course, also 5, let's see. Oh, 2.
One question.
Yeah, please.
Do you have an idea which might be the best?
It depends on the customer, of course, and then the environment where are you working. For some country, another is better, and for some country,
Is that the dependency on the regulations?
yeah, regulations, climate.
Also climate zones, technologies,
Yeah,
climate zones.
yeah, and then the building traditions. So there's, yeah, that's something I forgot to mention, that this was the first steps. And we are continuing in this access project, and we are making, we're going to make suggestions for this, and also suggestions for the policymakers, how to prevent these regulatory barriers, for instance. The work is continuing.
There is another question.
Another question.
Yeah, so I just wanted to say that the two new models that you are proposing are very interesting, but could you give a bit more detail about them? So the paper service and the community based.
Yeah, the paper services. Yes. Sorry.
You have an audience.
So the paper service is like that. It's a new model which requires totally new kinds of contractual agreements. Who is taking the risk and how far you're going to take the risk, how much they are willing to pay for that service. So it requires a lot of trust from the client also that this service provider is able to do that work. But it can be the service, or it can be just providing the energy, for instance. And the customer doesn't have to care where it comes from. He can say that, okay, I want it that it's totally renewable, for instance. That's one actually version. The energy as service is one of these options. There's a paper that, or then the storage as service is the paper that I've written with my colleagues.
Yeah. Cool.
I can comment on the second part.
Yeah.
Maybe, sorry, but maybe you could do it later, because we have one more presentation.
Okay, okay.
And the evening walk is about to start, so maybe.
Yeah, we keep it short, maybe. Thank you. Sorry for interrupting.
Don't worry, I spoke anyway too much.
No, at all.
Also, if anyone is going to the evening walk, I'm not sure if they wait.
Evening walk.
Yeah.
Departure is in the entrance at
5:30, so it's now, so if anyone was planning.
No, for 15 minutes.
4:45. Oh, sorry.
How long is the walk?
Until 7.
Until 7.
Until 7.
Maybe 40 minutes, according to you.
I don't know.
Okay. Let's go in the meantime with Ilaria.
There's always a 15 delay.
Thank you. Can you hear me?
Yes, give me 1 second that I prepare your presentation.
Yeah, sure.
So is no problem. Yeah, no, we can share the screen. In any case, we have it in the recording.
Give me 1 second.
So, then I can make
Okay.
Now I will be sharing this.
Okay, the floor is yours.
Okay.
Ilaria. Thank you.
Thank you so much. So let's introduce very briefly myself. I'm Ilaria Pigliautile and I work at University of Perugia. And here I'm representing the Energy to Peers consortium. So with some first results of this project, which is entering the third and final year of operation. So please, next slide. Okay. Very briefly, so since we are quite late, globally we know that we are passing by a climate change and climate crisis, so we need to intervene in energy-related CO2 emission to reduce our impact on climate, which has several other consequences, as we know with the SDGs, that all these targets can be connected somehow. So, for example, healthier cities, sustainable cities, or also peace. We know that the access to energy is very often cause also of conflict worldwide. Next. Let's say we are going to the European context. So Europe has set an ambition goal to become a leader in renewable energy and sustainable, let's say, development. So we have these two targets really important and ambitions: climate neutrality by 2050, and let's say to reach at least 40% of renewable energy in the overall energy mix by 2030 for the country. And this implies a change both in the energy system, which need to become from centralized to distributed. So we are expecting to have a future energy market based on many spots of distributed renewable energy sources. So changing consequently also the energy market. So from commodity oriented up to a market which is flexible and based mainly upon digital services. So to reach this goal, we need both important technological innovation and social innovation, as many presenters before me already highlighted. So in this framework, next slide, the RED directive introduced the Renewable Energy Community concept. So this community is open, voluntary, close, in close proximity to share local produced energy, whose purpose need to be to provide environmental, economic, and social benefits, and no financial profit, let's say, as primary aim. Then, next slide. Also the concept of peer-to-peer trading, so trade model, the possibility to exchange energy and to buy also, sell and buy energy among peers, thanks to bilateral, multilateral agreements, without passing by other levels, like, for example, in the next slide, there is a scheme about peer to community to peer. Next slide. But yeah, let's say just changing a bit the orientation of arrows and these flows that are money, energy, and information. And then let's say the next slide, it's just the most common market, let's say traditional peer-to-market to peer model. Okay, next slide. So here I'm introducing Energy to Peers. Energy to Peers aim at uptake next generation of European peer-to-peer communities through gamified platform that aim at empower user-centered trading mechanism. So we are going to do this in 3 levels. Please, next slide. Let's say the first level, try to keep notion experience from pilots of the Energy to Peers to develop the readiness level framework indicator based on 5 dimensions that are the organizational, institutional, market, and technological and user readiness. So we keep track of all these 5 dimensions. Then the second level, it's let's say the optimization of smart demand response mechanism in the most advanced communities we have in our project, aiming at financial saving, environmental savings in terms of CO2 reduction emission, and demonstrating local self-resilience. Third level, it's the adoption of community-based nudging mechanism. So through the developments of 2 different tools, 3 actually. So we have the readiness level indicator tool based on the framework we developed at level 1. Then we have the advisory app aimed at educate prosumers and generally consumers, members of the community, by sharing practices, best practices, experiences, so to have a behavioral change at the base, and also the roadmap, a regulatory roadmap, which is, let's say, the path we are envisioning for the member state involved in our project to reach a common final framework for the peer-to-peer energy trading in energy communities. So what are the pilots? Next slide. We are working in 4 ecosystems, let's say 4 member states that are representative for different ecosystems. So we go from the Netherlands, where we have 4 pilots, and which is assumed as a pioneer country, pioneer member state, since it's quite, let's say, it's one of the earlier adopter of this kind of organization. There we have a case study in Spain, one in Slovenia, and then 2 case in Italy, which is the laggard, because we are, let's say, in the we have very few examples of energy community already operating. That's why we are assumed as laggard. So let's say we have these 4 representative ecosystem. Now I will just briefly present 1 pilot per each country. So in the next slide, for example, you have the presentation of the schoolship community. This is a community in the Netherlands, in north of Amsterdam. It's a floating residential neighborhood. This was born in 2008 from the ambition of some residents that recognize a common values in their aim to realize an ecologically and socially sustainable neighborhood. So then in 2016, they became an energy community, and it was quite easy, let's say, this switch, since they are all moved from the same values, from the same vision of sustainability, and they could further be based on a microgrid serving the whole neighborhood. So they have just one connection to the main grid, thanks to the application of a dedicated regulatory sandbox for this neighborhood. Then, okay, the next case is the one from Spain. As you see, it's not still established energy community, but in Alginet, we are, let's say, in the consortium, there is this electrical cooperative of Alginet, and is representative of many cases in Spain, where this cooperative could represent, let's say, just the step before the energy community. So represent the possibility to uptake energy community in Spain quite quickly, since they have operate generally both as also DSO, so distributor, and energy related retailer, sorry. So for example, the cooperative of Alginet, they already have 4,000 active contracts, 88 prosumers belonging to their network, and 42 out of these already member of the cooperative. So once they could establish the, let's say, the legal entity as energy community, it would be a big occasion to share a big amount of renewable energy. And right now, just in terms of regulation, in Spain, they have an ex-ante split coefficient procedure to, let's say, provide incentives to prosumers. That's going to become an ex-post coefficient based on real-time data streaming, but this need a, let's say, switch into the digitalization level of the whole country, which is still far, according to, let's say, the most of our colleagues. Then the next slide, it's the Slovenian case, which actually you already somehow saw, because the demonstration pilot comes from the Compile Horizon 2020 project, which was presented at the first presentation of the session. Here in Energy to Peers, we are looking how to establish and formally establish this community as an energy community. So here we have 8 households, 1 small medium enterprise, and the mix of renewable, it's quite, let's say, we have both PV plants, micro wind power plants, and diversified storage systems. And that was possible thanks to this regulatory sandbox that allow to implement, to install more renewable capacity than the one that's due according to limitation regulation, which would have been 0.8 times the connection capacity, which means 10 kilowatts, for example, while now they have 150 almost kilowatt. And so they demonstrate to have up to 5 times the savings, energy savings, thanks to this experimental sandbox. And then the final pilots presenting is the Italian one, the next slide, where let's say it's the smallest one compared to the previous. We have just 4 members that are in 2 adjacent buildings located, and it was just established in January 22. It's quite diversified in terms of usage, and that's a good point for an, let's say, efficient share of production, renewable production. And just to understand the mechanism that brought these 4 members to become a community, let's say we have an initiators, which is the engineering studio, which is one of these 4 members, and they wanted to install and take advantage of PV panels above the roof, but they didn't own the rooftop. So they tried to involve all the other, the owner of the building, which is the residential unit, just being part of the community, and then all the others saying, okay, if we use this surface we have in common, so we live in the same building, we can share our energy. And it's not just self-consumption, because actually there are 2 buildings, and now that are legally established, are also trying to join the surrounding, because they are in a industrial area, and there is really the possibility to grow as energy community. So next slide, please. Okay, let's say that right now we made already a study of the state of the art in all this country, and we made some interviews, a focus group in all these different pilots, adopting the anthropological approach thanks to the cooperation of the Slovenian partner, which is University of Ljubljana. And according to these results, we could also frame some fixed points common to all the pilots that are key recommendation to engage citizens into this new kind of organization, like, for example, the existence of local frontrunners pushing for the establishment of this community, like in the Italian case study. Then it's a plus also to have already a spirit of cohesion in the community, like in the Sconship case, for example. In terms of, then, of course, we talk about trust in technology, that inclusive design for the technology to be adopted, and of course also clarity from regulation, because right now many stakeholders in this country, especially Italy, Spain, where we are a bit late, do not approach this kind of organization since they don't see clear the regulation. From this perspective, they don't understand which are the benefits proper of this kind of organization. Last slide, and then. Okay, next step of the project, we are just entering. So as I say, the deliver of this tool that are the regulatory map and the advisory app, the regulatory roadmap. So trying to bring all the member state context into the unique, same standardized European vision, and the advisory app trying to take advantage of this on all this experience to also boost new communities and the uptake of the energy communities in Europe. And that's all from me. Thank you for the attention, and if there are questions, I'm here.
Thank you, Ilaria. Any question from here, from the room? Here in Nice? Apparently no. Thanks a lot. Anyway, we will share also with your agree. Yeah, as you agree for according to the EU GDPR privacy regulation, we will share also your eventually emails, so to people who participate here or might be interested. And well, I think we have to close.
Yeah, we apologize, we have to close because we have another activity coming up as part of the conference.
It's been a pleasure being with you here in person, but also online. I hope you have a good experience here with us today. And we thank you, and we keep in touch with all of you. Thanks a lot. Bye.
Thank you. Nice evening to everyone.
Bye.